moving ahead in going deep into the topics now, when it comes to Windows Azure, as you all know that Windows Azure is a cloud computing platform from Microsoft. There are many things that Azure will provide you, but our focus for today in this particular seminar would be only talking about the various options Windows Azure provides you for storing your information, storing your data. So then the question comes, why do we require multiple options? There are applications which may use relational data store. There are some applications wherein you don't want to have relational data store, you want to store huge information in forms of files, could be videos, audios. So to accommodate all these things, Windows Azure provides you two types of storage services. One is your Windows Azure storage service, and the second service that you see is your SQL Azure. So on Windows Azure storage service, you have four options to go ahead and store data. You have blobs, queues, tables, and Windows Azure drives. I repeat, Windows Azure storage is further classified into blob service, a queue service, a table service, and Windows Azure drives. All these four options will allow you to store information in a non-relational fashion. So if your application demands that you have huge information in a non-relational format, Windows Azure Storage Services is the best option for you to go ahead and implement the data storage using the suitable options from these four. If you want to go with a standard SQL Server or a relational store on the cloud, people who are using SQL Server for on-premise hosting can migrate their application to SQL Azure on the cloud. So let's get started. Having known the various options that you have now, let's get started with understanding what and when do we go ahead and use these particular stores. So by now you definitely would have some questions on when do we prefer which storage. What options should I choose when I want a specific thing to store? So here is the answer to most of your questions. In Windows Azure Storage Services, first one to go with now is the blobs. Now if you have unstructured binary or let's say text data files, you can go ahead and store or upload it into blobs. The best example which I can give is probably you want to create a media library, create a photo book example where you want to upload photos, you want to upload videos and create a video library on the cloud. That's where your binary data would go in. So blobs would be the best option for you to go ahead and use different types of blobs to store audio, video, or any other unstructured binary and text data. Queues. So people into this webinar definitely would be aware of the way queues works. Various products which are available on-premise from various vendors. One is MSMQ from Microsoft. You have WebSphere giving product like WebSphere MQ. So on the cloud as well, when you want to communicate between roles. In Azure, you have three types of roles: a web role, worker role, and a VM role. So the intercommunication between these roles can happen through queues. Also, if you want to do some batch operations and you want to post some updates to the worker role or to a batch process, you can send in messages onto queues. So queues typically, which is a part of Windows Azure Storage Service, can hold messages which can be read, processed, and then deleted. Further comes the table service. These tables are not identical to the tables that we have in traditional RDBMS. The main difference here is these tables are non-relational tables. So if you have some non-relational structured information to be stored, then Windows Azure tables is the best choice that one can go ahead. Then, okay, before that, let me quote another example here. I'm sure most of us use Facebook. So a typical Facebook application where we keep sending some friend requests, so that could be best done through queues. You send a friend request, it goes into a queue. Similarly, when you want to post some comment, you want to post some update, that goes as non-relational structured data in forms of tables, and we want to upload our photos, we want to upload videos, that stuff can go into blobs. So together, blobs, tables, queues can work together and be used to have a backend for your applications. Windows Azure Drives is another good option. On our local machines, we go ahead and mount, or we go ahead and add VHDs, we go ahead and add drives. Similarly, if you have a role running in Azure, on that role you can mount a drive. You can mount an NTFS volume on the cloud, which will be accessible to the role in which it is mounted. So these are various options. As we move ahead, we will touch upon all these 4 options. I'll show you a sample code on how do we write a simple application for blobs, queues, and tables. For SQL Azure, I need not say much because it's a RDBMS which is available on the cloud. So to get started, the way it is structured is to go ahead and start creating or working with Windows Azure or SQL Azure. What we need basically is, if I go the bottom up on the slide, what I require here first is storage account. So if I want to work with blob, tables, queues, or drives, I need a storage account in Azure. Similarly, if I want to work with SQL Azure, what I need is a database server on Azure. So how do we go ahead and create a storage account? So you can go to my Microsoft.com site and register and subscribe to have access to Azure for one of your live IDs. The point here is, if you see on the slides as well, the key is through your live account, you can get access to various services available on Azure. So your live account has to be enabled. What you need to provide is your credit card number to get a subscription active for your live account. So I have a live account which I'm going to use for today's demonstration. So the developer portal is windows.azure.com. So this portal will ask you to log in with a live ID. I have already done that, so for me probably it will not ask. It will directly use the password just saved and log on to this. So this is a management portal through which you can provision your servers, you can provision your account, you can provision your services. So today we are not dealing with services at the scope of this particular session. I limit the scope only to storage account and database servers. Now here you see on the screen you have an option of creating a new storage account. The storage account will have options for you to go ahead and use blob, tables, and queues. Whereas if you go to a database server, this is where it is going to go ahead and create a SQL Azure database server for you. So if I come back to the slide, that's what you have. So through your live account, you'll have to get an active subscription, and in the subscription you can create a storage account, or you go ahead and create a database server for that. So let me start and create something, a storage account for you. So I'm going to start creating a storage account with some domain name. So I'm going to create a storage account. I'll use a proper subscription, and then probably the storage account could be a TechGeek demo dot the further details that you have. So this looks like it's already been used, so I probably would use some different name, and then in which area of the Microsoft Cloud I should be creating this particular storage account. So I choose the region as Southeast Asia, and I say okay. So this is as simple of creating a storage account. As I told you earlier, using Windows Azure, it becomes very easy for us to go ahead and manage an account on your cloud. So in another 1 or 2 minutes, this account will be provisioned for me. This is what I was referring to as easy manageability through Windows Azure portal. Similarly, while this gets created, we can go ahead and create a new database server as well. So let this get created. In the meanwhile, we'll go ahead and continue with the further topic on the slides. So if you have any questions, as I mentioned earlier, please do posting the questions to the moderator, so that towards the end I'll answer all of them. Now coming to blobs. How does the blob basically work? Now you can see here the first vertical you see as account. Just now we have created an account with some name. You can see the account name that gets created is TechGeek NW demo, and you will see, so the final URL of your blob will be TechGeek NW demo.blob.something. Similarly for tables, you have the same URL with tables. For queue, you will have the same URL with your queue as your intermediate suffix for this. So this is the account. So under one account, the way blobs are categorized or clubbed together is via the container. So your account can contain multiple containers, and every container will have set of blobs. So here in my demo, which I'm going to show you, I have an account with name NNWordK, has 2 containers, one container to store pictures, another to store videos, and further I'm going to upload images as blobs into container. In the second container of videos, I'm going to upload videos as blobs into containers. So this becomes the structure of your blob. For accessing, the access can happen through REST. The access can happen through the storage client APIs provided by Windows Azure. So this is how it looks like. So the complete URL for this situation will be like nnwordk.blob.core.windows.net/pix is the name of the container / the name of the blob. This is how a blob will be accessible to applications. This is how the blobs will be accessible to people through REST. I hope it is pretty much clear. So your account is getting created. Great. So the account has got created. So in this situation, the account name will be techgeekdemo.blob.core.windows.net/pix, the name of the container / name of the blob. Now once you have the account and you now create a container for the blob, let's see the architecture, or let's see some important points how blobs work. So blobs are further classified into 2 types. First, the block blobs. The block blobs are optimized for streaming. So the information like images, videos are best suited to be uploaded as block blobs, because you may want to stream that when it is sent to your applications or the clients. However, when I say a blob which is less than or equal to 64 MB in size can be straight away uploaded using the put blob operation, which is available via REST as well as the storage client API. But the blobs which are greater than 64 MB would have to be split into small sections which are called as blocks. Each block can be up to 4 MB in size, and then these blocks, once they are uploaded successfully in sequence, can then be assembled to form a blob. I repeat, blobs which are up to 64 MB can be uploaded straight away using a put blob operation, while the blobs which are more than 64 MB has to be split further into small chunks, which is called as blocks, which will be of size 4 MB, and once all the blocks are uploaded, you can sequence them for assembling into a blob using another API, which is put blob list. I don't want to go deep into the code in this seminar, but I thought it should be useful to you just to know how blobs will work. So you have a blob which are optimized for streaming. Next on the cards comes is your page blob. So page blobs are basically optimized for random read-write operations, and you don't have a limitation on this. So it's a huge size that a page blob can contain. So let's see what is the limitations, or what are the data points for a blob as well as for a page blob. As referred earlier, this is a summary slide for you. As referred earlier, we have blob which is optimized for streaming, and page blob which is optimized for random read-write operations. So when it comes to the blob, the size which can be there is up to 64 MB for a blob in one piece, or you can have blocks of 4 MB each, and then further go ahead and assemble multiple blocks as blobs. You can see the huge size that you get when you are working with blobs. A blob can be up to 200 GB in size, or can be a collation of, or can be assembled from up to 50,000 blocks, whereas a page blob can be of size up to 1 terabyte. That's really huge. The API that you use is pretty well listed out here. You have a concept called a storage emulator. When you work with Windows Azure, you cannot afford to always work on the cloud. You have an option to install storage emulator on your development machine, which could be Windows 7 or equivalent, and then you can test your applications locally without uploading that onto Azure platform on the cloud. So the limitation for that is up to 2 GB of size. So quickly go through on the sample code. This is how the structure of my seminar would be. I'll talk about a storage option. I'll give data points about that. Then I'll show you a sample code, and then we move next. So about blobs, now you know that blobs are of two types, page blob as well as blobs. So if you check out here, what we have is, here we first go ahead and create a storage account. Now this code, people who are working on .NET or any other computing platform, you would see that there is something like achieving or referring to a connection string. So you will have a 512-bit key, which I have not put here, but that's how the complete connection string for your storage account will be. So the protocol to be used, the account name, and the account key. So here is what you have. For gig, you have this as your account name, and the account key is where you can copy this account key from here, and that's what is the access key for your application. So once you have access to the storage account, the next thing you'll have to create a blob client using a storage account, which will be used to do all the operations on your blob. So if you see here, the next step 2 is what we create a client through which you can go ahead and then create a container. I've already shown you earlier that in the hierarchy you have an account, you have a container, and then you have a blob. So using the client, you get a reference to the container, so you go ahead and try to create a container with the name Pix, and you create a container if it's not existing. If the container is already existing, you refer to that container. Once you have the container, you go ahead and then create or upload a file as a blob. Here I decide that I want to go ahead and create a blob. I have an option where I should choose to go ahead and create a page blob or a block blob. Here, as I wanted to upload an image, I went ahead and chose block blob to be created. So I'm creating a blob with this particular name, and the file from my local machine will be uploaded onto the cloud at this location onto the blob in Azure. So this becomes how do we upload it. Similarly, if you want to download a particular file or download a particular blob into a file locally, so you can use this particular APIs to download this particular blob into the local file onto your machine. And obviously in a similar way you can go ahead and delete it. So this is a sample code which you can refer to. How do we go ahead and create an account, then use a client. Using the client, you create a container, upload, download, or delete a blob. So this was a very short introduction about what a blob is, when do we use a blob, and a quick code snippet on how a blob code will look like. Moving ahead on to queues. If you recollect what I said earlier, queues normally are used for asynchronous processing. One. Second, they are used for inter-role communication. Azure will have web roles which are end-user facing, whereas it will also have worker roles which will work as background processes. So queues is one of the best choice that one can make if you want to send some actions, if you want to send some commands, or you want to send some logs from your web role, which is UI specific, into your background processing, which is into your worker role. So the structure remains the same. Here in queue, you again have an account. Under account, you will have a queue, and under queue, you will have messages. So here, for TechGeek demo, this becomes your queue URL, whereas this becomes the account name which you have already given. So you have a queue that is there. You have an account under which you can create multiple queues. So in this particular screen scrap, what you see here is you have two queues which are created to hold various messages. The first queue that you see here is to hold messages which are coming from a web role. Web role is a UI specific application. So those messages which you want to pass from a UI into your worker processes that are to be put into the UI actions in my particular demo. Whereas if you do some logging activity, those messages can come under this particular queue. So queue will hold messages. You have account which will have multiple queues, and every queue further will have various messages. If you look at the URL at the bottom of the slide, the URL is pretty much the same except the last part. So here, what you see here, the important thing that you should be noting is you have a queue, then this is what is the queue name, and further you will have messages which can be retrieved using REST or your client APIs. To work with queues, logically you can have unlimited messages that you can keep posting onto your queue. The limit could be the size of your list storing that particular messages. Every message today can be of 64 KB. Earlier, in the prior versions of Windows Azure, this limit was 8 KB. Looking at the need, this limit of 8 KB per message is now increased to up to 64 KB per message. As I told you, typically messages are used to communicate instructions between various applications, so we need not store huge data. In case you need that, you need to store some information. What typically is the practice that people follow is you will just give a metadata or a pointer into the queue, whereas the actual object can remain into your blob. So you read the blob URL from the queue and then pick up the object from the blob and then start processing it. One very important thing that everyone should be noting here is when you work with MSMQ, you read a message, that message is removed from the queue. Here, the messages are not deleted after your read operations. The application which is reading the message should explicitly delete the message after processing. So in simple words, here message consumption is a two-step process. One, you read the message, process it, and once the processing is complete, you then go ahead and delete it explicitly. Now, why this is done? Now, on the cloud, there could be multiple worker roles who will be accessing your messages simultaneously. So what happens here is sometimes processing might get failed in between, and we don't want that the message processing is incomplete. So by default, every message will have a specified visibility timeout. So as soon as you read a message, the message becomes invisible to other people who are looking from the queue for a specified time. For instance, if application A reads a message, it will be made invisible, let's say, for 30 seconds. So when the second application tries to read the messages from the queue, that message will be made invisible for 30 seconds. After 30 seconds, if the message is not deleted, that message becomes visible again to anyone who reads from the queue, which means the idempotent behavior which is required to be there for your messages is to be implemented by the application reading the messages. So this is how a queue code would look like. Now you would see some similar things which will happen in all my code snippets. The first thing that you will always see is the storage account, which you will refer to a specific storage account on your cloud. Second step, though similar, slightly different. Earlier we had used storage account to create a blob client. Here I am going to use a storage account to create a queue client. A queue client is a class which I'll be using to work with messages. I want to create, I want to add, I want to read, I want to delete messages. Queue client is what is going to help me to achieve that task. So using the client, the next step would be to go to the next vertical that you saw in the figure. The next vertical was for queues to get created. So using the queue client, what we do is we go ahead and create a queue here. So UI actions, you already seen this particular keyword earlier in my figure. So UI actions is the queue which I have created. In case the queue exists, it will be referring it. In case the queue is not existing, it will create a queue and send me a reference to the queue client. And then I create a message object, and that message is added to the queue. Similarly, if you want to go ahead and read messages from the queue, you just have to say queue.getMessage. The getMessage method will always return you the message which is available as the first message in the queue. So as I told you earlier in the previous slides, it would happen that some messages are read twice in case they are not deleted after processing. So getMessage will give you the first message which would be popped out of the queue, and you can read the information from that message. Similarly, you can do delete operations. So this sample code snip will give you an overview of how do we create a queue, then how do we create messages, how do we add a message, how do we read and delete the messages. I hope this is understood to all of you. Then the next part is the tables. I repeat, these are Azure tables. These are not our relational tables that you see in SQL Server or any other RDBMS. So here you have an account. Under account, you can create tables, and under tables, you will see entities. Here, table will not have rows or columns that we normally see. Azure table is composed of entities, and entities is further composed of key value pairs, and that is why I call it as the schema is not fixed. Every entity can have a different set of key value pairs. So let's look at the details of Windows Azure tables. When you work with tables, the data is stored in form of entities. In the bracket, what you see here is the similarity which I wanted to draw between Windows Azure tables and relational tables. So when I say the data in Windows Azure is stored in form of entities, you can probably want to compare that in RDBMS to what you have rows. So you have multiple entities in the table the way you have multiple rows in a RDBMS table. Every entity is a set of properties. A property is a key value pair, and that's where I can draw some parallelism to columns. Now every entity is 1 MB, while the table can grow up to 100 terabytes. Again, a huge size to have. At max, a particular entity can have 255 properties, and those 255, this 255 number includes the 3 system properties which are added by default. These properties are partition key, row key, and timestamp. These are 3 system properties that you will see in each and every entity of your table. Why are they used? So the system properties, these names that you see here, names are reserved, and these names you will not be able to change. Okay. So it will be a responsibility of the code or developer who is using the table to make sure that when you insert and do update, you provide appropriate partition key and row key values. However, the timestamp values are automatically managed by the storage. The timestamp gives you when that particular entity was last modified. You cannot go ahead and do a change on that. However, for partition key, code will have, or the developer will have to provide proper values to it. So the complete entities of tables are actually organized by partition, and this is used in, the partition key is used in combination with row key to uniquely identify a particular record. In Azure terms, I can say to uniquely identify a particular entity. So partition key and row key together has to be unique. So to quote one example from could be, again uploading images. The partition key could be the name of the logged in user, whereas the row key could be the name of the image. So for that user, that particular image ID always remains constant. So partition key and row key together always are unique. The maximum size that a partition key and row key can have again is 1 KB. For both it is 1 KB. Now the various types which are supported in table storage, you will have int32, int64, string, double, datetime, boolean, binary. So if you see, most of the standard data types that you require are supported by the table storages. So if you want to see how it will look like, it's a two-step thing that I want to explain to you all. So the way tables, the way you'll have to work with tables is, the first you'll have to create a mapping of what you want to store. So this is like an entity model that you'll have to work with. So you'll have to create a class which is from the table service entity, and this entity class will have a mapping of all the values that you want to associate or you want to add into the table. So if you see here, for example, I'm adding actually 5 values to my table. So in a traditional RDBMS table, you could have 5 columns. But here, what you have is, I'm storing a nickname as string, caption, then I'm storing the photo URL, and along with that, what I do is, my partition key is the album. So the albums which I create becomes my partition key, and every album will have various photos. So as mentioned earlier, partition key and row key, it is the responsibility of the code and the developer to make sure that appropriate values are assigned to it. So here I don't have to create another properties for album and photo ID. I simply assign album and photo ID properties to partition key and row key uniquely, so that in every album I have a unique photo ID. So you have this photo entity class which works as an entity mapping for me for my table storage, and then comes the standard processes, standard steps that we follow. To start with, getting a reference to the storage account and creating a table client are the standard steps that you might have now seen for blobs, for queues, and now again for the cloud tables. So I use the table client to create a table with the name photo book, and then to actually go ahead and access the entity class, what I use is, I use a table service context class to go ahead and add, remove, or update my entity objects. So the table service context class object is going to give me properties like the methods like add object, update object, delete objects, and save changes. So what basically is happening here is, I'm creating a new object of photo entity where I pass the mandatory values and other details, and this entity object, I'm passing it to the service context, the add method object, and then I say save changes. As soon as I say save changes, that's the time where your information gets pushed back into your table storage. Similarly, if you select something, I'm using link here, so people comfortable with link can really understand it pretty fast. So I'm using a link query to get the entity object which has the partition key as this and photo ID with some value. Right now I've hard-coded the values, but this could come somewhere from the UI, and then I get the entity object. So this is how I can go ahead and select a entity from my table storage. So we have seen how do we insert the entity, we have seen how do we select the entity. In the same fashion, while I inserted the entity, I didn't have the nickname. Now I am updating the nickname onto the entity and then updating it back onto it. This update will not happen till I don't fire the save changes. The save changes method of the service context is actually going to push these changes to the table storage in Azure. Similarly, you will have something on the delete object as well. So that's about the tables. Coming to the last part from the Windows Azure storage is the Windows Azure drives. Now Windows Azure drives are similar to the drives that you map onto the storage as well as the local thing. So what basically we do is we upload the drive into a page blob. So the data of the drive is stored into a page blob, and it can optionally be cached into the local resource into your role. So the data is persistent here. Data is not volatile because it is stored into the page blob. So even if your Windows Azure virtual machine recycles, restarts, your information of your drive remains into your role. When the role restarts, because it's going to refer back the page blob which has the complete information of your drive. Now this drive can be mounted into your roles with the help of the Cloud Drive class, and once you mount it, it will be accessible via a drive letter. So similarly, the way when we use USBs on our laptops, you get a drive letter. In a similar way, when you mount a VSD onto Azure, you will have drive letters assigned to it, and then you can go ahead and use standard NTFS file IO APIs to access the contents of Windows Drive, just like you go ahead and access content from your local file system. So Windows Azure Drive that way helps for existing application to quickly mount it onto Windows Azure with the help of Azure drives. So if you see the way it looks like, important points to highlight here is from a storage account, what you do is you go ahead and create a Cloud Drive, and Cloud Drive will point to some URI which is for your page blob, and then you create a drive. If it is not existing, here I am specifying that the drive should be of 5000 MB, and then once the drive is created, I am mounting the drive. After the successful mounting of the drive, it returns me a drive path. As very similar, when you insert your USB, you will have a drive assigned to it. When you mount a particular VSD on Azure, you also have a drive path, and further then you can go ahead and use NTFS file APIs to read, write operations on the drive. And once you are done, you may want to unmount it or delete it. Unmount will only remove the drive mapping, but the data will be present. Whereas if you say a delete a particular drive, the associated page blob will also get deleted when you delete a particular drive. Focusing towards the last topic, that is SQL Azure.